All right, we're going to continue on multiplying and dividing rational expressions. The difference in today's lesson and yesterday's is the fact that we will have to factor and cancel before or after multiplying, but I very strongly suggest that you do it before we multiply. You'll see that afterwards is going to make things more difficult. So I'm going to play a video for you here. This is one I've recorded earlier on how we can use our calculator to graph, and I'm going to write as this goes through. All right, I was going to make this video to remind you all how we can use Desmos or any other kind of calculator to help us factor these different numbers. So this is actually one of our examples from Delta Math, as you can see. These are the numerators, denominators, and whatnot. Remember, anytime it crosses the x-axis is a solution, and the inverse of that is a factor. So I'm going to go ahead and take a look at this at first. The only thing that we are unable to get from this is a GCF. So we can find our GCF of 6 and 292 just by trial and error. But as you can see, I've got this graphed here. I'm going to go ahead and highlight this in color so we can see what this looks like. So this term right here, we have a crossing at the point -7. We have a crossing at the point +7. And then we have a bounce at the point 0, 0. So this is actually all of our factors. What we would have here is x plus 7, which represents our crossing at -7, 0. We would have a second factor at x minus 7, which is apparent from our factor 7. And then remember when we talked about multiplicities, we have a factor at 0, 0, which means we have an x value factor. And since we have a bounce happening at this point, that means that it is an even multiplicity. So this term has 4 possible factors, and we have identified 1, 2 of them, leaving us with 2 more, and they both happen to be here. So if we were going to factor this out, we would have an x squared from the bounce at the origin times x plus 7 from this point and x minus 7 from this point. So that would be our factored form. I'm going to move to the next term. I'm going to unmark that and mark this. So we have a factor because we have a crossing at -8. That would be at x plus 8. Since we have a crossing at 7, that would be x plus 7. And since we have a bounce at 0, we have a factor at x squared equal to 0. So this one factors out like that. We can take a look at the third. I also wanted to highlight something you could do on Desmos. You don't actually have to hit the shift 6 to get the x squared. If you just do x times x, like you can see I have done there, you can have it graph as well. So this is actually a difference of squares. We have a crossing at -8, which gives us the factor x plus 8, and we have a crossing at +8, which gives us the factor x minus 8. There are only 2 x's possible because it's x to the second power, so those are all of our factors. And then lastly, we'll take a look at this one here. You can see it's 2x squared minus 30x plus 112. Well, this one you've got to make sure you might want to look at a table if you're using your calculator. If you're using Desmos, you obviously can just click here and here. So our factors would be x minus 7 and x minus 8. This also would have a GCF of 2 because I see that these are all even numbers. We have to take that into consideration as well. So this is how you can use Desmos to help you factor these different. All right, so that gets us to this point here. We have a factored form. I hope that helps some of you. We're going to have some difficult questions on these, more difficult than we'll actually see, but if we prepare for these really difficult ones, when we get to ours, they won't seem as bad. So I'm going to first mark out any kind of cancel I can do vertically. And actually, one other thing I really should do is identify any excluded values. This one gives me an excluded value of 0. This gives me an excluded value of -8, -7, +7, and then +8. Notice the 2 had no bearing because that is not a variable. This 2 right here is the one I'm referring to. It does not have a variable, so it is not one of our excluded values. It's just a value in the denominator. So here we go. We're actually going to have a lot of this question take care of itself. Here's what I mean. Before I even multiply, I'm going to cancel anything that can, kind of like the x squareds sitting right over top of one another. I also have an x plus 7 over an x plus 7. I'm going to look over to the other side, and I see that there is an x minus 8 and an x minus 8. So at this point, we're back to what we were at yesterday. Everything that I can cancel vertically has been canceled. You can either multiply here, or you can cross out values from numerator to denominator. What I mean is, I'll do this in a different color. What I mean by that is x minus 7 is in the numerator, and there's an x minus 7 in the denominator as well. So those can cancel. I actually have an x plus 8 in the numerator and an x plus 8 in the denominator here. And I have, lastly, the number 6 divided by the number 2. So all of this example, everything took care of itself except for that numerator of 3. So the solution here, the simplification is the answer 3. Now, don't get too excited. We will oftentimes have things left to do it, but I wanted to pick one that we had that's very awkward in this situation. All right, let's take a look at this one. I want to point out some things that I expect to see on this as I go through. First of all, I see 2 terms up here in my numerator, so I'm not going to be very surprised if I have a difference of squares. Also, I see an x minus 7, so I'm very much expecting an x minus 7 to show up in the denominator either here or here. Looking at this one, 90 does not have a factor of 7 at all, so it's probably going to be this one. But I want you guys to start thinking ahead on these problems. Where is this problem going? All right, first thing I want to do is go to each of these things and factor out a GCF. So my numerator here has a factor of 2. I know this because they're both even numbers. So this would factor down to that. And surprise, surprise, we have a difference of squares. I look at my denominator. It also has a factor of 2. So when I factor out a 2 from 2x squared, it's just x squared. A 2 from 8 is 4. And a 2 from 49 is 45. 2 from 90, excuse me, is 45. Make sure you keep your signs all squared away there. I look down at the bottom right. Well, the lowest degree in this polynomial has a degree of 3, so I can actually factor that out, leaving me with x squared, excuse me, plus 2x minus 63. At this point, you can take these values to Desmos or your calculator or whatever you want to do, but we can do these in our head maybe. For instance, we have x squared minus 81. Well, that's the difference of squares. The square root of x squared is x. The square root of 81 is 9. And we recall, hopefully, that the difference of those two would be 9 and -9. and then the 2 would just tag along right there. So we have a double factoring there. If you don't like the way that I do it vertically, you are more than welcome to work horizontally on this and just continue to put equal signs and move this way. I actually like that a good bit. Takes up a little bit of space, but I notice students make less mistakes when they are a little more organized with this. So you could have written this thing horizontally just like that, and then continue moving. But since I've already started this vertical method, I'm going to stick with it. Again, just like yesterday, do what works for you. And here's something that works for me, and I suggest you get accustomed to this. Well, the factors of 45 that can become 4. Think about looking at the numerator and getting kind of a pathway in which they're talking about going. Well, 9 and -9, well, that's a good place to look. 45 has a factor of 9, 9 times 5, and 9 and 5 can become -4 if it's a -9 and a +5. And then the 2 again just carries down. I could have canceled that 2 because it does not affect the excluded values, which we will take a look at in just a second. But it's okay that it's there for now as well. Now, again, think about x minus 7. It doesn't have to be in the denominator, but there's a really good chance that it is. And in this case, again, it is. X minus 7, well, 63 divided by 7 is 9. So my factors that work are x minus 7 and x plus 9. So we've got this thing all factored down. Before you go factoring, or excuse me, canceling, we need to make sure that we determine our excluded values. In other words, what are the x values that we cannot use? Well, from here, we learn that we cannot use the number 9. From here, we learn we cannot use the number -5. From here, we learn that we cannot use 0. From here, we learn we cannot use 7. And from here, we learn we cannot use -9. If a number happens to repeat, don't write it twice. So we got a lot of excluded values here. Even if they cancel, they remain excluded values or restrictions on the domain. Just make sure you know that. All right, so let's see what cancels vertically. I'm going to rewrite this just to make sure that we all see what's going on here. So my numerator is now 2, x plus 9, x minus 9. My denominator from the first little series there is 2, x minus 9, x plus 5. The other side is just simply x minus 7. I would suggest to some of you, make sure you keep that in parentheses. Keep you from making a few mistakes. X minus 7 times x plus 9. Now I like to cancel vertically instead of going across the way. So I see an x minus 9 and x minus 9. I see a 2 and a 2. On the other side, I see an x minus 7 and an x minus 7. Now I can start to look diagonally as well. Well, this has an x minus 9, and so does this one. So we can cancel those. So my numerator, everything from the numerator has canceled. This is a 1 and this is a 1. So my numerator is 1 times 1, 1. My denominator, well, these things have all canceled down to 1 except for this little x cubed and this x plus 5. So when all is said and done, that big old problem ends up being just all of this stuff that we see here. By the way, I don't necessarily suggest this one because it's a good bit of work. If you would have put this in y equals, y1 equals, and you put the result in y2 equals, their tables will be exactly the same with the exception of maybe a few error readings. But if they should have exactly the same value with maybe, like I said, just an error here or there that one of them has that the other does not. All right, we'll look at the last example now. Now, as we look at this one, don't panic. This is just me giving you an opportunity to practice these. I've only given you one example. This is not likely something we are going to see. Lots of factoring, lots of stuff going on here. Just have a process. First thing I want to take a look at is see if I have any GCFs that I maybe could take care of. And in this case, I do have one. I see a 3. I see a 3 coming out of this term right here. This is 3 times x squared minus 49. Now, this is actually great news. We have a binomial divided by itself. Anytime this happens, we can cancel those, but we don't want to do it yet because we still have to account for the excluded values that are involved with those. So we're going to go ahead and factor everything out. Again, this is going to take a little bit of time here. We need the factors of 24 that can become 10 in order to factor this. Well, the factors that can become 10 that involve 24 are -6 and -4. So this cancels out, or excuse me, factors out to that. My numerator, or my denominator, correction, I need the factors of 42 that can become 1. Well, 42 is 7 times 6. If the 7 were positive and the 6 were negative, I would go there. And again, well, look, I got an x minus 6 that's going to cancel. Don't ever cancel anything until you have established excluded values. Let's go up to our numerator here. We have a difference of squares going on here because the x has a perfect root of x. X squared has a perfect root of x. And the 49 has a perfect root of 7. So remember, we split these up just like you see me doing here. One will be positive, one will be negative. And then the last little factor we see here, the factors of 28 that can become 11, cheat off of the one above it. I see 7. Okay, common themes, 7. 7 does go into 28 4 times. And then sure enough, there's our factor, x minus 7, x minus 4. Now, I do need to factor this out just to state excluded values. So I'll do this in a different color actually, because I'm going to put it right back when I'm done, because I have an excluded value to take care of, but those things are going to cancel one another. So what I need to do is find the difference of squares, which I've already done this one. Remember, right here. So this is x plus 7 times x minus 7. I will be putting that one back though, because I want to just cancel the x squared minus 49, excuse me. So let's go down here and state our excluded values. X cannot be equal to -7 because of that, 6 because of that, +7 because of that, +4 because of that, -7 has already been stated, +7 has also already been stated. All right. Now we also have a keep change flip situation here. So another thing I will have to consider is this will be a denominator in a second, but since I've already done that, I don't have to worry about it. All right, so here we go. We've got all of this done. We need to next do our keep change flip situation. I would suggest though that you cancel now because I don't want to rewrite all this stuff. So anything vertically can cancel right away, kind of like our x minus 6 being over an x minus 6 cancels instantly. I have an x minus 7 divided by x minus 7. Those cancel immediately. And then the one that I really liked because I could cancel an entire binomial, x squared minus 49, excuse me, x squared minus 49. So I'm going to rewrite this real quick. What I have now is x minus 4, x plus 7, times x plus 7 over x minus 4. And over here, remember our keep, change, flip situation. We have division, so we're going to keep everything to the left the same. We are going to change division to multiplication, and we are going to flip 3 over 1 to 1 over 3. Now, anything from the top can cancel anything from the bottom. Well, everything's going to cancel from our binomials because those are identical. Those are identical. So we end up with 1 times 1/3. So this whole thing ends up being simply 1/3. Like I said, guys, this is not going to happen a lot, but it does happen where we just simply have a number here. Right. We should have questions here. Make sure that you speak up, ask those questions as well. I gave you one of these. These are just kind of a challenge question, so don't be intimidated by it. Or none of these really. This is really just as difficult as we can find, but again, if you can do these, everything else should seem pretty easy.